Today we're going to learn about compositions of trig functions. Compositions are when you have multiple functions, one evaluated inside of the other. Right here you see I have an example. It's sine and then in parentheses the inverse sine of square root of 2 over 2. So the inside function is what you have to evaluate first, and then you evaluate the outside function to give you your final answer. With problems like these, you're evaluating both sine and the inverse of sine, so you have to be very careful as to what unit circle you're using. So this is the original unit circle. And the original unit circle is used to find all trig functions. Over here, I placed what I created as the inverse unit circle, and this is used to find inverses only. Okay, so you have to be specific and you have to understand how to identify which unit circle you are using. So let's come down to the first example set. Number 1 says the inverse sine evaluated at sine of 5 pi over 4. So this right here is just a standard trig function. It is not the inverse, so therefore you are using the regular unit circle. I'm going to say original unit circle. So 5 pi over 4, the sine value at that location, is right here. So here's 5 pi over 4, and the sine value is negative square root of 2 over 2. That means I'm going to replace this function here with that value. I still have the inverse sine on the outside, but inside of the parentheses, we specifically know that sine of 5 pi over 4 is equal to negative square root of 2 over 2. Now this right here, this is an inverse. So we are going to use the inverse unit circle. If you recall from the previous lesson, inverse of sine can only happen in quadrant 1 or quadrant 4. When I created this unit circle for you, I actually highlighted all your sine values in pink. So anything on this pink curve right here is going to be where your answer could be found. That's it. It can't be found anywhere else. So we're looking within these two quadrants for a sine value that's negative square root of 2 over 2. And that happens right here, corresponding with your answer of negative pi over 4. So now that we evaluated the total function, we know our final answer is negative pi over 4. And that's your answer. So you start with the inside and you finish by evaluating the outside function. If we look at number 2, we have inverse cosine of 3 pi over 4. We're going to start by identifying 3 pi, or the cosine value of 3 pi over 4. So let's look at our original unit circle. 3 pi over 4 is located here, and the cosine value is negative square root of 2 over 2. Now we're looking at an inverse. We're evaluating when the cosine or the inverse cosine is negative square root of 2 over 2. So I'm going to come up to my inverse unit circle. I'm going to point out to you that the cosine inverse can only occur in quadrant 1 or quadrant 2. So I highlighted all of these values in orange. Sorry. Anywhere on this orange curve is where we can find our answer. So I'm looking for when the cosine value is negative square root of 2 over 2, and that happens right there, corresponding with 3 pi over 4. So my final answer is 3 pi over 4. You have to alternate between these two unit circles in order to identify your answer. So, of course, you could just use one unit circle if you thoroughly understand what the inverse is, but I find it to be helpful to alternate between the two. So look at this unit circle if you're dealing with regular trig functions. Look at this unit circle if you're dealing with inverses. That way you're looking at two different things and you can clearly keep your answers separated. Number 3, we have the inverse cosine of sine of pi over 3. We'll start by identifying sine of pi over 3. That's from the original unit circle. At pi over 3, the sine value is square root of 3 over 2. Now I'm going to use my inverse unit circle to evaluate the inverse cosine of square root of 3 over 2. Remember, cosine inverses only occur in the orange highlighted area. We're looking for square root of 3 over 2, which happens right here, corresponding to pi over 6. So my final answer is pi over 6. And lastly, number 4, which throws a little bit more in here because we're dealing with secant and tangent. We're going to start by evaluating the inverse tangent of 1. If you recall from yesterday's lesson or from the previous lesson, tangent is on this unit circle, and I highlighted all the tangent values or where the tangent values can occur in blue, so they can occur in quadrant 1 and quadrant 4. We're looking for when the tangent value is 1, and I had already found all the tangent values for you. They're these numbers here. So we're looking to find which or where the tangent value is positive 1. And that happens right here. That corresponds to pi over 4. Okay, so now we need to use the unit circle to find your secant value. And just a quick reminder that secant of whatever angle is equal to the r value. If it's on the unit circle, the r value is 1 over x. So we are going to have to do some calculation here. If we look at our original unit circle at pi over 4, our x value is square root of 2 over 2. And that's all we're going to need to find the secant value. So if we calculate this, we have 1 over square root of 2 over 2, of which we can multiply by the reciprocal. That gives us 2 over the square root of 2. However, you can't have the square root of 2 in the denominator, so you multiply the top and bottom by the square root of 2, giving you 2 square root of 2 divided by 2, of which you cancel your values of 2, and you're left with the square root of 2. So all of that work gives us the solution for secant of pi over 4. Okay, I'm going to go ahead and do the on your own section if you guys want to follow along. I'm not going to explain as I go through it, I'll just show my work. Tomorrow is a quiz on lesson 1 and lesson 2, so make sure you're preparing for those, meaning you need to understand how to use both of the unit circles. Email me if you have any questions, and have a nice day.